business math. I don't think I've made a video for you yet. Most of my videos have been for 7th grade. Not that they're the best, but just had to pick one class, and the videos that they had online are not as great. So I'm trying to limit what I'm able to do, but just wanted to check in with you guys and hope to go over a little bit of the assignments. The first couple of weeks have been a whirlwind, so hoping to have a better rhythm. Please reach out to me. Let me know how things are going. Tell me what's not working well. Tell me what is working well, and trying to keep it minimal and yet still kind of keep us up to date with what we need to do. I don't know what will happen with our business plan project. I tried to get onto DocsX and download them so I could share them with everyone and we could work on them from home. But that wasn't working when I was up at the school, and I'm trying to be limitedly there as someone with a weakened immune system and a son who has a weakened immune system. So anyway, doing my best on that. We'll just have to pick up where we left off or figure that out when we get to it. And I've not forgotten, have some ideas about doing a budget, kind of like Dave Ramsey type thing. See how we can figure that out. So just bear with me. We do need to get through a couple more sections of our book for sure. So we'll probably start with that and then see what it looks like at the end here. So anyway, this is going over section 310A and B about compound interest. So we talked about simple interest. And when we had simple interest, we knew that the interest was equal to the principal times the rate times the time. Okay, now whether you fully understand where this compounding formula comes from, we're not going to get into the depth of that, but it basically just means that the bank is going to say, hey, I'm going to make your interest based on how much money you have in there, and then when there's more money in there because interest was added, then I will also take an interest as a percentage of that, and a percentage of that, and a percentage of that. So if you are earning money by investing your money somewhere and it has compounded interest, you're going to make more than simple interest, just as a concept, because you are going to be then able to make money off of the money that you have already made and that interest as time goes on. So this is simple interest. And today we're going to look at compound interest. And so our formula for that is A equals P times the quantity of our interest. I'm sorry, this is of 1. Sorry, that doesn't make sense. 1 plus the rate to the power of N, okay? And we have to be careful because N is the number of interest periods that we can have. And so that's going to be something that's given to us. So it's kind of similar to our time in a way. Again, it depends. Sometimes this is quarterly, sometimes it's monthly, and it just depends. However many times that money gets compounded is how many we're going to take to this degree. Okay, so I'm not going to go over the why, where this all comes from, and again, you probably read through this. We're not going to go through the examples necessarily, just going to kind of go over some of the answers, but I did want to just plug in one little bit of information here and talk about something. From example 2, when you looked at these yesterday, you had to find the balance on something that was 2 years with a 3% interest, and it was unique because it was compounded quarterly. So the first thing you had to do was say, if it was compounded quarterly, I know that quarterly means 4 times a year. And if it was 3% interest, I'm going to represent my percent interest as a decimal. Okay, so once that's written as a decimal, what I need to do is actually divide that by 4, because what I want to know is how much is it for the annual, or what is the annual rate, or how much is it for every 1. Okay, so if that was actually happening 4 times, well, let's undo that and divide it by 4. So that's going to be 0.0075, and now that is the number that I can use for my rate. Remember, this was my percent. And then I can go ahead and say that N is going to be the number of times this happens. And I'm not just going to plug in a 2 because it's 2 years, because that's not really how many times it's happening. I have 2 years, yes, but it's happening 4 times each year. So that's really 8 times. So your n is going to be an 8 there. Okay, so just kind of want to go over that a little bit. The principle is pretty simple, so plug that in. You will need to use a calculator, and I do want to talk about making sure that you do what is inside your parentheses first. So add 1 to something, take it to the power, and then multiply it by p, unless you have a scientific calculator that can plug the whole thing in at the same time. Be careful with your parentheses, but you're going to run into some problems if you're not going step by step. So parentheses, exponents, and then your multiplication. That just comes from, please excuse my dear Aunt Sally. If you remember our order of operations, remember that multiplication and division and adding and subtracting are grouped together. You do them together from left to right. Okay. All right, so from 3.10a, please excuse my handwriting. It is hard to write on this tablet, but bear with me, okay? All right, well, let's just kind of go over some of our answers here. Please feel free to reach out to me, Instagram, email, text. I'll video chat if you want to go over how to do any of these. My intention is not that you have to watch some really long video today going over exactly how to do all of these problems, but that we can just kind of practice a couple and get our answers, okay? All right. So for number 9. I didn't have to do number 1. Number 9. Y'all, numbers 1 through 8, they're good information, but you really have to understand what part you're looking for. They're just looking at the interest, not how much is your balance in your account, which is okay, and that's important to know. But what's going to be more important, having to pick what's most valuable from this section, is just being able to know what our full balance is. So plugging in to your formula, I guess it should be an A, is equal to your principal times 1 plus your rate to the power of n. Now from section 310a, 9 through 15, all of them are just compounded annually. So we don't have to do any of that funny stuff that I just showed you over here. We don't have to divide by 4 and multiply by 4 and change our n. Okay, just plug in, it's kind of straightforward, okay? So I'm going into more depth than your first one here. So your principal was 1,000 that you put in. Your rate is 1 plus. Now, careful, it's 2%, so make sure you use it as a decimal. And the number of years is 2, and that's, again, n isn't necessarily the number of years. It's however many times that interest is compounded. Well, if it's compounded every year, it's 1 time a year, and 2 years would be 2. So for number 9, you should get $1,040.40. Now, if you want to know just how much interest you earned, well, you just subtract your principal. We put $1,000 in, so we didn't really make that. We just made $40.40. All right. I'll go a little bit quicker through some of these as we just kind of go over the answers. Number 10, you should have, again, plugging the same thing in. Your n value is going to be a 1 here. You'll have 5,150. It's even. Okay. Number 11, careful with your percentage. So you should have 850 times 1 plus, and this is 0.015. Okay, it's 1.5%. So 1.5 is equal to 1.5, and I still have to divide by 2. Okay, now you could plug that in as 1.5% if you have a calculator like that. Take this to the power of 5. Again, if you don't have a smart I guess like a graphing calculator, something that does these different sections, make sure you add this together first. 1.015, take it to the power of 5, then multiply by 850, and you should get, this color here, $915.71. Okay. For number 12, I guess it doesn't let me go over any further. Let's just do this. Number 12. All right. Again, your percent here, I'm just going to kind of lay it out. You can plug these into your calculator. 1 plus 0.0275. Careful with your fractions. To the power of 3 should give you $1,936.37. Number 13. You should have 15,900 times 1 plus 0.0325 to the power of 7 gives you $19,889.31. See how valuable this time is? The longer you leave stuff invested, the greater it grows. All right. I guess that's true short of an economic crash due to coronavirus. But anyway, if your interest rate stays the same, that's not affected by an investment. Okay. Let's do this for number 14 to the power of 9. Gives you $5,962.69. All right. And last but not least from this section, you can probably figure out there's always going to be 1 point something. Okay, you don't always have to just put it in as 1 plus. You can figure that out as you go. And $2,713.33. Okay, how'd you do on those? I hope all right. We are now moving on to section 3.10b. I am not going to walk you through every single one. You should have done most of these yesterday, but I do want to make sure we kind of talk a little bit about how these work. All right, so Ginger Patty's parents, what a name, invested $5,000 in a savings account for Ginger when she was born. That was very nice of them. Okay, so let's just already write that down. The bank has paid 6% interest compounded annually on the account as long as Ginger has had the account. So we know that it's 1 plus, that's part of our formula. That's her rate. What we don't know at this point is how long. Ginger just turned 18 and she wants to use the money for college, so how much does she have? Well, it was compounded annually. That means I don't have to do any of that funny dividing stuff. It's just once every year, okay? And then when you plug that into your calculator, you should get $14,271.70. All right, number 2 is where it gets complicated. So, well, let's read it and walk through it, okay? On April 1st, Dr. Petroff deposited $10,000 in a new savings account, which pays 3% interest annually, compounded quarterly. So let's stop right there. We know his original amount is $10,000. We know this formula, and I have to put my rate in here and my number of times it is compounded. Not per year, but just overall, okay? So what I know is that I have a rate of 3%, but it's not going to be a 3 here. Remember, this is kind of what we talked about before. It's compounded quarterly, so it's 4 times every year. So I really have to divide this by 4, and I'm going to get 0.0075. And when I add 1 to that, it's just 1.0075. And then to the power of n. Now, this is where I'm not just going to say, oh, how many years and how many times is it going? I have to really work through this problem. So let's keep reading. It says interest was added to his account on July 1st and October 1st. So if something is compounded quarterly, it means 4 times a year, so every 3 months. So really all we care about is that it has happened twice. His interest, don't worry about figuring out how far apart they are. I just need to know that it was compounded twice. So my n is going to be a 2. And once I put that in, I can figure out how much he's going to have on October 2nd. It doesn't really matter that it's the 2nd. It just happens to be after that second time. So plug that into your calculator and you should get $10,000, $10,151. So it doesn't really say that it had to be rounded, although that's what our book says here. When I did it, I actually got $150.56. I like that answer better, but I'll take either one. It doesn't really say to round it all. So technically he wouldn't, like, the bank's not going to round it up. So I like that answer better. Either one's okay, though. All right, keep going. Number 3. Nancy Grant sold her house and made a profit of $35,500. While she decided how to best invest the money, she put it into a savings account that pays 3% interest annually, compounded quarterly. So let's pause right there. It doesn't really matter that she sold her house. All we need to know is that all of a sudden she has $35,500. If you get that much money, don't be the guy that the master gave 1 talent to, who buried it in the ground and didn't even earn interest, okay? Be the guy who got 10 talents, like Jesus's parable, and who turned it into another 10 and had 20, and be like the guy who had 5 and turned it into 5. Find a way to invest it well, even if it is just in a savings account, to get some sort of an interest. All right, so she has this much as her principal. That's how much she's going to put in, and we know that it is a 3% interest annually, but it's compounded quarterly. So here's that same number, keeps popping up. It's going to be 1 plus, and this is my new rate, which I'm just going to skip right to this step here of adding it to my 1. Now what's interesting then is my n. That value of n is what's really important, however many times it happens. So if it talks about years, you will multiply by 4 because it's happening 4 times every year. But we're going to read and find out how many times she ended up compounding or having this compounded. All right, and we find that she put the money in on July 1st and then took it out a couple months later. Remember, she was kind of just deciding the best way to invest her money, and so she probably figured that out in a few months. That means she only left it in July, August, September, October. That's 3 months, which is a quarter of a year, so it's probably compounded just once. So my n value is going to be 1. And when you plug that into your calculator, you should get $35,766.25. Now this is answer to A. How much did she withdraw? This is how much she was able to take out. Now it was only a few months, but hey, isn't that more than what she put in originally? If she had just been sitting on that money, not in a savings account, she wouldn't have earned that extra interest. Okay, so that's part A. Part B says, well, how much interest did she earn? Well, I just need to subtract $35,500, because that's the initial. She didn't earn that money now. She made that money as a profit from selling her home. So when we subtract here, we should get $266.25 interest earned. That's part B. Okay, on to number 4, and then just one more and you'll be done for the day. On January 1st of 1 year, Mike deposits $1,000 in a savings account, and it pays simple interest compounded annually. So you don't have to worry about doing this dividing, it's just compounded annually. All right, so we've got our 1,000, 1 plus, and we'll have to figure out the interest rate in this case. We'll read to that in a minute here. Okay, he deposits $1,000 in. We know that's going to be his principal. That's why I wrote that down there. On January 1st of the following year, he withdrew $1,050. Okay, now this is a lot of algebra, kind of working this backwards. It does say simple interest, but it's still compounded annually. So I'm just going to go over it, how we plugged it in this formula, since it's from 310b. Because it's to the power of 1, that just means everything inside of here is only happening once. And so really, I can ignore that in a way. So in order to get my r by itself, I really want to get rid of my 1,000 over here. And I'm going to divide by 1,000. I think I skipped informing you on some of this. I'm sorry. I'm just going to back up here. It says on January 1st of the following year, he withdrew $1,050. I missed that, telling you that part of information. So 1 year later, I'm going to make it compounded once because it was compounded annually and he left it in for 1 year. Now he withdrew this much money, $1,050. That means he made $50 interest. Okay, and I'll show you an easier way to do this in a minute also. But algebraically, I'm going to show you this way. So that means 1 plus r, this is eliminated, I already eliminated this, is equal to 1,050 divided by 1,000, which turns into 1.05 when you do that in your calculator. Now, if 1 plus something gives me 1.05, well, then I could subtract 1 from both sides, or you could think about this logically. Also, r is going to be 0.05. Well, that's great and all, but we like it to be as a percent, so we're going to multiply by 100, add the percent sign, and 5% is my rate. You also could just say, hey, 50 divided by 1,000, because if I have $50 extra, divide that by 1,000 is going to tell me what percentage, because 1,000 is my original amount, it's my principal. Okay, and then I can take the interest, divide it by my principal, and I will still get 0.05. So either way, you want to do that. Okay, I would say this is a lot easier here, but you'd have to understand the concepts of it without going through the formula. Okay, we're finally on the last one. This one's a little bit difficult. If you did not get this one, don't worry about it. We don't really have a formula right now in order to do something like this, so we're going to have to do this multiple steps at a time. On January 1st, for 5 years in a row, Martin deposits $10,000 into a savings account, which is a 4% simple interest compounded annually, so we don't have to divide. If it's compounded annually, that's really nice. If he makes only those 5 deposits, he doesn't take any money out, how much does he have in the bank 10 years after the first deposit? All right, so a lot's happening here. He has $10,000. He puts it in, and we know that it is at a 4% interest rate. So 1 plus my 4%, which is 1 plus 0.04, or just 1.04. Okay, all of this here goes into my parentheses. And then the first amount, if he leaves that in for 10 years, it's going to be compounded 10 times, right? Well, here he is coming around the next year, so I'm going to add these together because he just keeps putting this into his bank account. So then he's going to have $10,000, and it's the same interest rate. But this guy, it's only sitting in there for 9 years because he put it in the next year, okay? And then that's going to happen again. It's the same interest rate, but now the third year he comes around, it's only sitting in there 8 years. And you get the picture as you see the pattern emerge here. He's going to continue to do this. Five times. Oops. So 1, 2, 3, 4, 5. The last one is just going to have to the power of 6. And he stops. Maybe he's out of money after putting that much in. I would calculate each one of these out on your calculator and then add them together. You get your grand total of $68,536.42. Well, I hope you're doing okay. I hope that this is helpful to go over this a little bit. Tomorrow you will be doing you'll watch another video today. You'll also need to do your thinking back, and I'm going to do another video here in a minute, and that will be checking your thinking back. All right, well, have a great time working on that. Please use a calculator. Don't forget that when you are solving a proportion with fractions, when you get to number 11, that you might want to just turn those into a decimal. When you're adding fractions, find a common denominator, use your notes. Let me know if you have questions. Please reach out to me. Ask people around you, ask classmates, start a group chat. But we'll see you soon.